I call this talk Putting It All Together in the Client because I want to sum up this part of the course where we've been dealing with client-side technologies by putting all these various things together. Single-page applications, model view controller patterns, REST, APIs, AJAX, fetch, all these different variations in design pattern that I want to talk about. So to do that as a framework, I want to talk about from MVC, the model view controller pattern again, but now we're going to talk about porting it down to the client side basically. Um, so to do that, I want to do a quick refresh on our model view controller pattern. If you remember the steps on the server side, we had a server side pattern where you made an HTTP request to a controller, and the controller could have that router in front of it as we had before. But the controller is responsible for finding the right thing to call in the model. Remember, the model is the world model state. It's that set of data and behaviors that is application independent that can be used across many different applications and are presented and adapted in different ways. Those projections are what makes our application logic, if you will. So the model goes ahead and executes that business logic, that app indication independent logic, and then returns the results to the controller, which then finds the appropriate view. That view, in our case, which is read-only, would have should have read-only access to the model, the projection of the model that was produced, the state of the model, if you will. And we turn around and use that in a practical sense to populate templates like Pug and EJS, right? And that's how we got our view, which rendered HTML entirely on our server side, and then we wrote it down to the browser with that render call. And all that was done server side driven. And while there's still a fair number of websites that do it that way, the fact of the matter is over the last 8 years, 10 years, and certainly really a lot in the last 4 to 5, the server-side rendering approach has given way to the API driven approach that we've been talking about, and that's why the prevalence of AJAX, the new Fetch API, these kinds of things, if you will, have taken over. And nowadays, if someone's writing a web application, they are looking at client-side technologies to drive the application behavior. Is there a role for the server? Sure, we still have those APIs. We're still accessing world model state. We're still writing applications across web and mobile and Internet of Things devices and all these kinds of interfaces. And that's in part why we include mobile in this course that we'll do next. But I digress. We are talking about that MVC pattern as a refresher. We talked about this notion of SOC, separation of concerns, the distinction of responsibilities, the separation of responsibilities in the system. Our presentation mapped basically directly to our view. The model, though, it comes from our data sources and business logic, so the model really took into account these two levels here. This was the view, this was the model. This is all refreshed from earlier in the course, and the controller really isn't in here, if you will. Controller is an artifact of the design pattern to route and find the right entry point into here, but it's not directly part of the responsibilities of the system, if you will. What we're going to talk about today is that model view controller pattern with some variations of the model controller pattern. One of them we mentioned before, we'll mention again, is the front controller pattern. Again, Node.js and Express use that. The model view presenter variation from Microsoft, something called model view view model, in different variants you find in the browser. And then we're even going to evolve past MVC and take a peek into what's going on very recently in how folks thinking may be changing about MVC, which, by the way, is a very active topic of conversation in the developer community now. As a foundation for this, I want to return to our notion of UI state. That UI state is a concept that's very natural for desktop GUI developers, and I don't care if you're using Qt, I don't care if you're using TickleTK, Java Swing, FX. If you write a desktop GUI, you typically have widgets on the screen, and those widgets on the screen are backed by some kind of data. That data is referred to as model, right? I do talk about Java Swing, even though I know there's not a ton of Java GUI-based apps, desktop applications out there. There's some, but Java at one point, to delve into the history a little bit, used something called the AWT, the Abstract Windowing Toolkit, for you to write your GUIs. And it had this very lightweight event model with listeners bound to widgets and so forth. But there was no explicit representation of the data that backed a widget on the screen. And when Swing came along, it created these models. You go look at the Swing API and you look at a tree, a foldable list, and other widget types, you'll see there's an underlying model you bind to it. All right. If you were a .NET developer, this would, or in the old days, the COM and DCOM model, it would feel very familiar to have this widget backed by data, if you will. Fowler described this years ago as the presentation model pattern. And so here's the structural side of the pattern over here with this class diagram. Here's a sequence diagram about how different things talk to each other. We have our view, we have our presentation model, and then we have the actual world model thing, right? So this is the GUI widget I'm talking about. This is the presentation model. And this is the world model, all right, album. And this UI state here is what I've called UI state, is the state of the presentation model and the state of the widget, right? Is the widget enabled? Is this album window, is it enabled? Is it displaying things and so forth? The presentation model pattern is basically giving first class standing to this data backing, and it's a little confusing from our perspective because we've used the world model and always kind of implied that it was world model. That was the only model we have. Now we have this model that's the presentation model. The presentation model is transient. You instantiate a GUI, you back it with that data gets updated, and then transactionally may update the world model state. That's why it sits between, right? It's sitting here between the view and the model. So this is our traditional view, this is our model, and now we've got this P model sitting in between here, all right? But again, Fowler was giving a name from a design pattern perspective of how we work with data that is bound to a GUI in an application. Another way to think of this is this model is still application invariant or independent, right? It's used across many applications, but everything this way is bound to the GUI. It is application dependent. Presentation models are application independent. Again, they are part of that projection of the world model state onto the data that a particular GUI will use and represent. All right, enough conceptual talk. Well, a little more conceptual talk. This is, again, more reminder. That was the MVC part. That was the presentation model design pattern that we're going to use. Another quick refresher translating back into our web space is, remember our motivation. And this is all reviewed too from Ajax. But we had these back and forth where this redraw was an entire redraw the page, what became an update to the DOM. All right, this whole notion of Ajax being introduced said we can start updating part of the GUI, and the fact that we could do that meant now we could start backing parts of the page with calls out to the world model state to get some data or invoke some behavior. All right, so Ajax got started down this path of looking at a page and saying there's different parts on here that I can manipulate by a call out to the server by just doing this part without, having to redraw all these things and update them and recreate their state. And once that happened, Ajax was initially known, this XHR was originally known before it was really called Ajax, was kind of a trick. This is a really cool new thing that Microsoft introduced and all the browsers are going to get it. A few years after that, folks started to realize there's actually a real architectural design thing going on here where we can re-envision our pages and our GUIs in a more traditional way. All right, that's why I have this slide on here. The real point is we evolved to these new design patterns that were actually more traditional GUI-like. Okay, now traditional GUIs were still MVC driven, so we'll get to that. But now I could start to envision this round trip via Ajax and this partial page redraw as giving me a better mechanism for trying to approximate traditional desktop GUI application programming. That was done before, by the way, even before we got to this update. The redraw tried this, and you can go old school and look up a technology called JSF, Java Server Faces. Java Server Faces would actually have component widgets it was trying to use. And would actually inject some JavaScript to try and do over-the-wire bindings of what's on the browser screen and what was the actual data backing it. But of course, those, JSF's actually, there's still a fair number of websites, more than you would think, that are actually out there running it. JSF did that via a whole redraw, and then they eventually caught the update bug. But JSF was trying to do this thing pre-Ajax because folks wanted the desktop GUI event-driven model for providing that interactivity that we crave for user interfaces. Okay, Microsoft again. So they did Ajax. All right. We have a model view presenter type pattern or presentation model pattern. Microsoft gave us something called MVP, Model View Presenter, as a client-side variant of MVC. Right? They realized that the passive view in MVC with the active event handling of the controller was a bad decoupling because of the controller sitting out in the server, and the view is something that's rendered in markup down in the browser, and this round trip right at that point hurts responsiveness. Right? Now views, as they became more JavaScript enabled and snazzier with CSS, could now handle interactions, but could also delegate interactions to the presenter, and the presenter could mediate interaction with the model. All right, so the view didn't directly interact with the model. There's no projection of model objects that the view directly access, but instead this presenter served as that intermediary, basically served as that presentation model interceptor, if you will. I showed you in that sequence diagram a couple slides ago. All right, being more active now instead of passive allow the Ajax approach a cleaner design, meaning this ad hoc thing I'm talking about that went on for a couple of years turned into something that now we had a design structure for doing. So that was one thing. We started to see initial client-side technologies and homegrown frameworks around the MVP pattern. Still can find those today. They also gave us something called MVVM. Usually written with a dash in the middle here, and written long way is written model view view model, and it is written correctly. It's view model is a concatenated thing, because the view model again is this thing that sits in between that the view binds to. All right, view model is associated with a term called two-way data binding. And this is something that has come about in the Angular framework I'll talk about in a minute, but in fact had been around a long time back in the days of ASPX pages on .NET frameworks for the web. What would happen in those frameworks is the Video Studio toolchain would look at the design of your pages and the bindings, and you create these data binding files which would be used to automatically generate code that would be called code behind. It's code that sits behind the widget to interact with data, is basically do it. Now it's a very Microsofty term, but effectively that's what a view model is. It does two-way data binding. It binds the view, the widgets, with the data that the widgets have, so that if there's an update to this, then this is automatically updated. And if there's an update to the widget from some other place, then the model is also updated. So it's called two-way because of the bi-directional nature of that binding. All right. The MVP and model view model patterns are based on this desktop-oriented approach. They play well on the web given that there's increased bandwidth, meaning when I need to do access to the world model state, I'm not suffering from horrendous latency, and certainly the bandwidth required, the chattiness might be more, but the size of information going back and forth is smaller because it's usually much finer grained and entire page redraws again. But even in these patterns, the formal notion of the MVC controller still sits on the server. So we have this thing going on in the browser with widgets and their data sitting behind them in the DOM that we're updating. But if I wanted to do something interacting with world model state, I was still going out here interacting with the controller, and that controller was talking to the world model state, and the databases and all that, and still following the longer round trip, if you will, of the MVC pattern that we talked about on the server side. The question became, should we actually take some of this and move it into the browser as well? Should we start making those routing decisions and marshaling decisions and so forth down in the browser as opposed to doing it on the server? And the thing is, you can do it if you want to. You can write a controller inside the browser in vanilla JavaScript if you want. The JavaScript will respond to all events with AJAX calls. So let me clean this up a little bit. You know how messy I get. So let me redo this in the little white space I have in this slide. So what we are talking about is we are sitting here in a browser doing an action. The user, our user over here is interacting with the UI in the browser, doing some changes, and some of those changes require a call to the server over AJAX or fetch, all right, to the server to do some stuff, all right. So I can do that to these services, and now and when I do that, what I'm really returning is data, because now I'm moving the view all in here, all right. So what I'm really returning via this call back to the world model state is some Marshall JSON. That's the projection of data I want to incorporate into the DOM or into the presentation model. All right. And I can do my partial redraw with the DOM and keep that SPA flavor of applications that we've been doing. Your JavaScript, though, has to make intelligent decisions at this point now as to what goes to the server and what doesn't, and has to be aware of where information is, where behaviors are, because some of them could be implemented in the JavaScript in the browser if we moved them there. Some of them could be data that you've offloaded in bulk from here all the way into the browser, and you already have it, so you can go get it locally. Maybe you stashed it in session local storage. Maybe you buried it in the DOM. Right now, I have to have more design-aware, application-aware JavaScript that has to know where information is that it wants to act on. It's not such a clean separation of concerns anymore where the model even is, let alone the controller, all right, in this new way of thinking that's AJAX enabled. So in effect, we started to split our model view controller pattern, and that gets very confusing, all right. So variants on the design pattern involving, and one rationale that was applied was this notion of a front controller. So the front controller is a web-specific pattern. This is from Spring's documentation, and this is an entirely server-side view of front controlling, right? This is done via, Spring is a Java technology. That's why it says servlet engine runs inside Tomcat there. But as an abstract diagram, it still works for us because basically we want to split our front controller, some of our routing logic, and we want to push that down to the browser and put the front controller there. We want a first order router of what to do when events come down in the browser to be more responsive. All right. It figures out what actual controller needs to be invoked, what should be done in the browser versus what should be done in the server. The controller this front controller can be API aware of what's going on, right? And it can decide whether or not we access data locally, access data via AJAX or fetch, or do a complete page redraw because we've gone to such a different context in the application that it actually requires us not to stay in single page mode, but to actually go to a new URL on the server and get another application, if you will. So logically, our application is made up of components that are multiple single pages wired together based on decisions that this routing logic is making. And so it all has to be compatible. All right. We've seen some of this splitting already. When we talk about, in fact, I'm going to switch to that. We've seen some of that already when we were looking at our MVC pattern. This is the Node.js express diagram we had for MVC. And what I'm saying is we had routes specified in here, right? In Express, that was, you know, an app.get on some URL. Here now the route is a user interaction event. In a minute we'll talk more broadly about event, but let's say it's, you know, it's a user clicking on a button or doing something, and we want to route that to whatever place can best handle it. And that place could be directly in the client side, or it could be an AJAX call, because this is still sitting on the server with the world model state. All right. So this part's been moved to the client. This part's been moved to the client. This is no longer an HTTP request. It's now that event or user interaction. And we're no longer sending HTML fragments or HTML pages back to the browser. We're typically sending JSON, because that JSON is going to be incorporated into this view, which, by the way, has been moved to the client side. So we're not pug and EJSing anymore. There's a variety, view.js, mustache, handlebar. I mean, there's umpteen number of templating technologies for the client, just like you did in the server. And these things now will consume the JSON, figure out how to render what it needs to render, and do the DOM manipulation for us. So, you know, it's a bit messier. And it's not just a bit messier because I'm drawing all over this slide. It's a bit messier because we've taken our pattern and we're starting to split it apart and pull it at the seams. And anytime you take the responsibilities of a system and you're starting to map it onto different physical aspects, and in some cases may even be thinking, I'm really feel like I'm splitting them down the middle. Even some of the model data, you know, can wind up in the client side if we want to optimize. It becomes very messy to be well organized and disciplined in your development team to do this correctly. Right? If developers aren't of the same mindset of understanding what the design rationale and principle is for splitting the model view controller pattern across the client and server, you're going to wind up with a mess. It's a disaster. And folks are starting to realize that. All right. And that's really all I'm talking about when I talk on this slide. I should probably have them out of order, about splitting our MVC pattern. All right. So again, let me try and summarize more concisely. As user interaction, user responsiveness, you know what, I'm going to go through this in a little more detail. Let me bring this up. There was a number of factors going on at this time, right? And some of these things are business factors, and some of these things are technology factors. And things, you know, didn't happen on the web for one reason. It wasn't like, oh, this is a great new technology, that's going to change the world. It was really a combination of things going on at different levels. So I'm going to back up, and again, I'm going to tell you one of my stories. You know, in that decade from 2000 to 2010, you know, a number of things went on. We went from, you know, pre this over here, we were doing doc-centric until we were doing app-centric. We started doing XML, but XML started to give way to JSON. We had, as we did app frameworks, we started to have server-side application frameworks. I mean, Spring is popular in Java now, but Spring was evolving from a rejection of the EJB model, which you probably never heard of, Enterprise Java Beans on the Java side. So we had server-side frameworks evolving over time. And we kind of got to 2010, and what we're saying is moving forward, we've been slowly growing in popularity toward client-side programming and client-side frameworks. And the same kind of thrashing that we see now in client-side frameworks, we saw back here with server-side frameworks. There were tons of those as well. In the context of the history story, what else was going on? We also went from, you know, own your iron, I'll call it, meaning you'd go out as an organization and buy your own servers, and you'd put them in a closet somewhere, and you'd figure out how to build your own little mini data center, and you'd own your own iron. Iron is an old school term for owning your own servers. All right, and your operations people were people who understood CPU purchasing logic. How many CPU cycles was I buying when I bought a 40 CPU box for a big database? Because we had big databases for a long time, and that's how we bought them. That's how we bought Oracle, was price per CPU. And this evolved into rack-mounted, rented servers. So now I was renting servers, but I go down to a local data center. I'd say I need to host these boxes. Maybe I did buy them, and I'm renting the rack space to plug it into the wire and the underlying network backplane. Or maybe I was even renting the server itself. And of course, this is eventually went to the cloud. All right. And the cloud introduced that notion of things we hadn't talked much about before: elasticity, multi-tenancy. The ability, right? And elasticity is a business concept more than a technical concept. Sure, there's a technical manifestation of it, but elasticity is the ability to rent computing cycles or buy them in a temporal term based on the nature of my traffic, the ability to scale up and scale down. So now I didn't have to go buy physical servers and plan for peak capacity load. I bought as many computing cycles as I need on the cloud, right? This was enabled by technologies like virtual machines, which eventually is given way to, not fully given away yet, but getting closer to giving full away to containers, so I can run that down the software process pipeline, topic for SER422. Okay, all this backdrop, what does all have to do in the context of our conversation? The business proposition, I probably shouldn't have gone back here yet. The technology proposition and the business proposition overlapped. They were both forces on seeing applications evolve in this way to these client-side frameworks. We had a need for more user responsiveness. Standard response time benchmark for the web back, here somewhere was 7 seconds per page. That's outrageous today. Now we want the page to load and be interactive with it, and we want to interact with it before the page even may fully load, and we want the page to feel continuously interactive, not with this redraw kind of mentality. Obviously, we had more mobile devices. What that meant was a change in the bandwidth dynamics of things. It was a change in the physical device characteristics of things, right? More devices, more rendering layers, driving technologies like CSS and the responsiveness stuff that was part of an optional module. The expensiveness of doing this, helped drive adoption of that into the equation, which means we started to want to move things to the cloud. That also drove this client-side framework API driven thing we're talking about. All right. How so? Well, when I put things in a client-side framework and it runs in your mobile device or your laptop browser or your desktop browser, guess what? You're paying for the CPU cycles. All right. Server-side driven apps back in this day and age, and ones that still run now, have a whole completely different performance and scalability estimation and capacity planning model. The amount of iron that you got to buy, the number of CPU cycles you need, the amount of memory, right? Server-side state, when we talked about session-oriented middleware, right? Very expensive stuff because it's a hard computational resource that the provider is paying for over here, okay, with their servers. Once I took and I started using stuff on your device, right, I gained CPU cycles. I gained memory because you as the end user, as the consumer, you're paying for that stuff. Me as the provider, I don't pay for that stuff. Now I can pay for the cloud. And by the way, my cloud can just serve up APIs. And our APIs in that RESTful way we were talking about like to be stateless. They answer a request, do a behavior, return some stuff, and they forget about you until the next time you come back. And the next time you come back, they act like they never saw you before. Most APIs are stateless. That means I use less CPU cycles. I use a lot less memory and those hard computational resources. I may be chatty or I may have a bandwidth issue, but that's kind of a different conversation. The point being is now I can be elastic. I can pay for only what I need, and I can even open up my APIs, right? Another part of this is APIs started to become open. I wasn't doing custom integration in closed API land over here, B2B integrations. I was opening up my APIs to the world and saying, write all your apps in my ecosystem model. Again, a business driver, right? We haven't really talked about ecosystems. This is a technology course, but these were drivers. You wouldn't have seen client-side applications based on the technology power alone. You read some blog posts that says client-side applications are better and kick butt because this and this. If it's an entirely soul-sided technology story, they're only telling you half the story. A lot of economics, business proposition has gone into this evolution, which again I've made a mess of here as I normally do. But the point is, a lot of drivers in both the technology and economic space as we learned how to become far more efficient in how to build and deploy applications. Are we done with that, by the way? Of course not, right? We have security concerns. We have splitting of the MVC concerns at the topic of this talk. We have, so many client-side frameworks. We don't, the development costs are through the roof because we're always revising them. We have the fast-moving pace of mobile devices and what their capabilities are all the time, and that's now the predominant computing device. And next is the Internet of Things and your Alexas of the world and your smart homes and the like, all leveraging those same APIs and server-side infrastructure in that true world model state / app agnostic way. That creates challenges for our testing and QA processes as well, in addition to our design. So, to a certain extent, we've traded some problems for other ones, but in general, we've moved forward and be able to support the rapid innovation in Internet of Things space, in mobile space, and even in traditional web browser land because this architecture continues to evolve. All right, that was my soapbox conversation. Let's go back to today's topic. That's really what I wanted to say, though, instead of this discussion slide, to tell you the truth. All right, so still forgetting where I'm going. All right, so I talked about that. I talked about evolution. So where folks are is basically saying, in that broader context, and as I'm still looking to maximize my user responsiveness, as I'm looking at more powerful computational environments, as I'm looking at the nature of interaction on the web and a world where everything's on the network type of thing, this round trip slog, I would call it, of the traditional MVC pattern, even refactored to the client side, is stretching its limits, right? MVC has been known for 2 decades as Bible in verse for web applications. And again, remember, MVC wasn't created for the web. It's not a design pattern for the web. It was created by the Smalltalk community back in the late 70s, right? Shared a paper with you on that. It was adapted for the web, and then every framework that has come out and approach has been judged in the context of how it does MVC. But now folks are starting to think differently. Now folks are starting to question and look at new patterns that are emerging as an alternative to using client-side MVC. So, and this is a current trends thing. I mean, what I talk about in the next 5 minutes is probably not going to hold sway next year. We'll see how it turns out. But it's kind of a current events. And I mean from like 2016 to now, which is 2018. This is the kind of things that are going on. And I wouldn't even say this is what most people do. This is just what some of the conversation you will see out there in the blogosphere, if you will, about modern web application development. The first one is make sure, go fully UI component based. The best example of this, I mentioned the JSF story on the server side before, but the best story that you can think now is what a very popular framework called Angular did. Angular had its first version, Angular 1, or what's called Angular JS, that was basically a straight manifestation of model view model, complete with two-way data binding. And they've changed that. They still do two-way data binding, but in their Angular 2, and now it's up to something like Angular 7, they changed from being model view model to being fully component based. That component based means UI component. It wanted to encapsulate the data and behaviors and the wrapping of the presentation model with the widget into its own component, distinct from the other components, and then try and wire them together. And this is very ugly. I mean, I hate Angular 2. I got a statement out on Blackboard as to why that, but I think it's a mess, in part because it's very difficult to do when you're talking about the HTML5, JavaScript, and CSS stack, because one component has to incorporate all three of those things. So you get into this multi-file management kind of thing. I put out some optional content that walk through doing a few simple components in Angular 4, I think it was the version I was using at the time, and it's just god awful. I mean, I think that, and in fact, Angular's popularity is starting to go down. I think in part because they did that architectural change. The learning curve went up. The intrusiveness, your ability to maintain the code, has gone way up, and I think folks have just rejected it. Now, that doesn't mean other folks aren't doing it. You are seeing other frameworks also be a bit more component oriented. I will tell you though that more and more folks are just sticking with a view oriented framework, which means they've almost punted on this separation part and just said, we know now that we want to do the client side using view rendering technology solely on the client. So we're going to get really good at that. React, Vue, these kinds of things do that. And less popular and less understood and less dominant in the marketplace are ones that try to go to other parts of the MVC pattern and still do it. Frameworks like Flux, right? You may like Flux, but you know, Flux doesn't dominate the market space by any stretch of the imagination. So some of this stuff is still really, I would call it a state of thrashing. I just don't think that this has found fully its settling point yet. But component based, I mean, some folks even present their component based framework still in MVC light. They still consider it an MVC framework, just turned around from a component based perspective. Another pattern that folks talk about, and again, they can still talk about in MVC variants, is what's called unidirectional data flow. And this is talked about like it's some big new thing, but in fact, it's really a rejection of the two-way data binding concept that I said Microsoft started with code behind, but Angular has done. Meaning when you go into an Angular application, when the UI model changes, the underlying presentation model, the widget changes, what you see in the screen. But if you go into the UI state and start changing things, so does the underlying model. They are tightly coupled, which means you don't even you don't have a separation of who the system of record is. You start typing something into a text area on a widget, it automatically gets bound in the model. There's no intermediary, there's no validation step. It just does, well, there's a validation step, but it's done differently. Where unidirectional data flow basically says the underlying model, so the model part, not the view part, is going to be ground truth, and things are going to flow this way. They're not going to be bidirectional, right? Like we saw way back here when and again, I'm scribbling all over thing, I know, but they're not bidirectional in this sense. It is a one-way unidirectional data flow. That saves some practical performance considerations, things that are beyond the scope of this class to understand, but it was faster and better use of resources, but it also helped us decouple our code and be a little bit more efficient in terms of the things we want to do in code. The third one, this one is truly new and interesting. Well, it's new compared to MVC, but it's not new in terms of design pattern. It's applying yet another set of design patterns that originated elsewhere in software engineering, but applying them in a web context. And in this case, it's viewing what goes on in a browser runtime and what goes on in your JavaScript processing as processing a sequence of events in a stream-like fashion, a stream of events. In this way, it's almost like Node.js. You have these incoming events and things to do and things to react to. That's why it's called reactive. This reactive, by the way, is not the React framework. It's reactive functional programming because it's an event processing stream where you're going to assign or attach functions to those incoming events, and you're going to be constantly processing them, usually in an asynchronous way. I'm talking about libraries and frameworks you hear of like RxJS, RxJava has one, and other ones like that. Folks are now starting to envision the browser environment, if you will, as this live event processing environment where the events could be the incoming of data from the network. They could be other things in the browser telling you events, things like plugins. They could be user-oriented events. They could be timeouts. We're starting to get back to an analogy of almost like things we talked about in Node when we had the different kinds of things that could go in the event loop, right? And that's kind of what it reminds me of. It's really a particular manifestation of the observable pattern. You assign functions as to observe different events on here and to execute in their own decoupled, encapsulated way. So this asynchronous continuality is what I don't think I said that right. Asynchronous continuality of single page applications, where my app is just always processing these things that are coming in and going. It also enables some things we haven't talked about in this class. I mean, there's things you might have, peer-to-peer, web sockets, other ways of getting events that are more push-oriented. And again, getting out of this mode of I do something, round trip, I redraw, I do it again. So this pattern 3 reactive functional programming, I can tell you from my perspective as somebody who's been, who's older than the web and has been doing this for a long time, that this is something that even though observables and events and streams are things that have been around forever, applying them in a web context and how that's going to turn out is a pretty interesting new and new idea. So I'll be very excited to see how that turns out. Okay, all that being said, to summarize, our app architectures have evolved through that 6th style, meaning going to the client side. And even within the client side, we talked about single page applications, API driven applications, the evolution of the MVC pattern, and now even beyond the MVC pattern, that there may be new things that we look to do. So a variety of forces at play. I'm not going to reiterate them here because I went through a whole messy dialogue to describe that. But it's an interesting turnover time to me in web mobile IoT and these infrastructures. For the last few years before this, I would say it was driven, the operations side with containerization kind of dominated the conversation. Now we're kind of getting back to, from the developers world, the way we write applications is once again going through a period of rapid evolution. I would expect, like I said, the last 10 minutes is something that's going to change totally next year, and I'll have to say something else because I think we are in a state of churn. I think you have to be very careful if you're out there in the real world about where you place your bets, right? I mean, React is a wonderful framework, and folks are doing that. But 2 years ago, it was Angular. This thrashing of frameworks and so forth. I don't think we're done yet. I think folks are going to continue to evolve. We're also, by the way, one last trend I want to mention I didn't put on here. What I also find interesting is, we talk a bit about taking traditional desktop UI programming and porting it to the web. Now folks are taking web programming and starting to write even desktop applications, if you will, on web technologies. So for example, if you have time, maybe I'll post a link to it. Check out a framework called Electron, right? Or check out new languages like Kotlin. Very interesting concepts there where folks are, and they're not the only ones, but like Electron's very interesting because you're basically taking web technologies and packaging them in an app deployment architecture, so now you can write a desktop application for it. Imagine writing one piece of code or a significant overlap of your code that runs on app code. I'm talking about it runs on mobile, web, and the desktop now. So think of the benefit. I mean, one common tool chain, one training of your development team. Maybe full stack developers won't be unicorns because they're going to need to understand that full stack in order to write applications across all these platforms. I would personally argue that this is a horrible platform to set a technology stack to use across all the platforms, but that doesn't actually matter. What matters is what's the most popular, what folks are trained up on, what's tooled out, and how that ecosystem develops. And a lot of folks are going all in. on the full stack, even for desktop development. So again, brand new stuff that hadn't seen before. Interesting to see if it continues to grow in that direction or peters out and we see something else in its stead. The next 5 years I expect to be a very interesting time for this type of development. And with that, I'll wrap up and close this part of the course on client-side development. We'll do a little bit as we move forward in the mobile platform. We'll still be talking about client-side technologies and API-driven in the terms of hybrid apps, but we focused on how to do that in mobile. This really kind of closes out what we're talking about conceptually for client-side development.